Okay, in this video I'm going to go through a few questions taken from the ordinary level junior cert with regard to functions. First question says, fill in 4 missing entries in the diagram, and here is our function. Very simple one, x squared. Okay, so any number we put in, we just square and we get back out our other number. So any number we put in as our domain, we squared, we get out our range number. So we put in 5, we get out 25. We put in 3 and we should get out 9. We put in minus 6, and minus 6 squared is plus 36, not minus 36. We put in 0, 0 squared is 0. And we put in a number, and when it's squared it's 49. So what number squared is 49? 7. Next one. Write down the range of the function. The range is the numbers that we are getting out. So 25, 9, 36, 0, 49. Alright. And this question here, it's nothing really to do with functions, but we may as well answer. So they're just looking to see what 3 to the power 7 multiplied by 3 to the power 7 is. But when we're multiplying indices, we add the power, so 3 to the power of 14. Right. This question, draw the graph of the following functions in the domain minus 2 to 2. Okay, so the function is y equals 2x plus 3. Put minus 2 in for x. So 2 minus 2 plus 3. 2 multiplied by minus 2 is minus 4 plus 3 is minus 1. So when we put in minus 2, we got out minus 1. So minus 2 minus 1. There's our point. Second one, put in minus 1. 2 multiplied by minus 1, minus 2 plus 3, which is 1. We get out 1 when we put in minus 1. So minus 1, 1. Then our next point. Next we put in 0. 2 zeros are 0 plus 3, that's 3. When we put in 0. So 0, 3. The next point. Put in 1, 2 ones are 2, plus 3, which is 5. We get out 5 when we put in 1. So 1, 5. And when we put in 2, 2 twos are 4, plus 3, which is 7. We get out 7 when we put in 2. So there we go, and we just have to join these, and it's a straight line. Okay. Draw the following function then. Okay, this function is y equals x squared minus 1 in the domain minus 2 to 2 again. Okay, we put in minus 2 then, minus 2 squared minus 1, which is 4 minus 1, which is 3. So we put in minus 2 and we got out 3. So it's there. We put in minus 1, we get 1 minus 1, which is 0. So we put in minus 1, we get 0. Minus 1, 0. There we go. We put in 0. 0 squared is 0. Minus 1, so we put in 0. We got minus 1. Put in 1. 1 squared is 1. Minus 1, which is 0. So we get out 0 when we put in 1. And that last one. Put in 2. 2 squared is 4. Minus 1, which is 3. So we put in 2, we got out 3. There we go, and we draw our curve. And there we go. Okay. this question, we have a graph of the function fx. On the same axis we want to draw the line gx, and gx, function of that, is x plus 3. Okay. It's a line. If it's a line, I could, put in minus 3 for x, find the point, put in minus 2 for x, find the point, minus 1, in for x, find the point, and so on all the way up to 5. But remember, it is a line. So all I need to draw a line is 2 points. So I'm just going to put in 2 points. I'll put in minus 3. Okay, put in minus 3 for x, plus 3, minus 3 plus 3 is 0. So when I put in minus 3, I get out 0. So minus 3, 0 is here. And I put in 5 this time. So 5 plus 3 is 8. So when I put in 5, I get out 8. So 5 and 8 there. Join the 2 points. There we go. Done. Use the graph to write down the points of intersection. Points of intersection here, which is minus 1, I suppose 1.7. I would say if I drew it perfectly with a ruler, I would probably get 2 maybe. And up here then, point that they intersect is 5, 8. Next one, another function kx. Here, another function k. Is x squared minus 2x minus 1, and they want us to work at the value of k3. So what that means is instead of having x, we put in 3, and anywhere I see x here, I again put in 3, in brackets of course, and I just work it out. So 3 squared is 9, minus 6 minus 1, which is 2. There we go. So this question, it's a junior cert higher level, and it says the 3 curves A, B and C are shown in the coordinate diagrams below. 2 of the curves show a function of x, the other curve is not a function though. Put a tick in the correct box to show which curve is not a function. Okay. Now remember we said in a function that if we put in a number into the function, as in we put in one domain number, it can only give us out one number in the range. So for example, if we drew it like this, let's say 2, 3, and this was 4, 5. Well, that would be a function if I put in 2 and I got out 4, and I put in 3 and I got 5. But if I put in 2 and I got 4, and I put in 2 and I got 5 as well, that can't be a function. So let's see if any of these graphs, if I put in one x number, do I get back out 2 y numbers? Well, in this one, if I put in an x number here, I get 1 y number, 1 y number, 1 y number. Okay, so it's only crossing the graph, I was only crossing the curve in one place. So that's definitely a function. And this one, if I put in x numbers, say minus 1 and 0, I'm actually only getting 1. Here again, it's only crossing the graph in one place. 1. Okay. So no matter what x number I put in, it's still only crossing the graph in one place. So b is a function. Well, let's see. If I put this point into the graph, it'll cross it once, once. Okay, so far. Now it crosses here. So if I put in this value into my function, I get out this value for y, whatever that would be here. Look at this, it crosses it again. And if I put in this value, it hits it once, twice, 3 times. That can't be a function. Okay, so C is not a function. Okay, next question is out of the book. So a liquid is poured at a constant rate into these 5 containers. The height, HCM, of liquid in the containers is plotted against time in seconds. Match these containers with their graphs. Okay, well, the steeper the curve on these, that means the faster they're filling up. Okay, so if we look at, let's say this one, well, that should fill fast and then start filling slower. So if it fills fast, well, then it should be steep and then not so steep. So if we look for one that's steep and then not so steep, this one looks pretty steep here and then not so steep at the end. So that'll be A. B then, well, B will fill slowly enough, then in the middle it'll fill a bit faster and then slowly again. So it'll be flat enough, then it'll get steep and then it'll get flat again. So if we look for one that's flat-ish, then steep and then flat, this one, so that'll be B. If we look then at, let's say, D, well, D is just going to be a constant. It's not going to go any faster or slower how it fills up, right? So we're just looking for a straight line there, a constant I suppose, rate of fill. So it's going to be this one. And the last one then. So if we look at C then, C is going to be relatively flat because it's going to be filling very slow, and then gradually it's going to get quicker and quicker, and then it's going to get very quick. Okay, so if we look at this one, it starts off very slowly filling. Okay, it's a flat enough surface, but it's getting steeper and steeper, and then it's shooting up. So this will be C. And the last one then, well, it's going to fill very quick down here, and then it's going to get slower once it gets to here. So look, very quick, then slower. Sorry, not this one. This one, very quick. Then it's getting slower on the middle. It's getting quicker, and then it's shooting up because it's going to fill really quick here. Okay. Right. So in this question, we have a graph showing the journey of two motorists, Darren and David, and it gives their distances from their hometown. So on the y-axis we have the distance they are from their hometown, and on the x-axis we have the time. So for instance, at 11, which is here, well, if we go up here, David is 75 kilometres from his hometown, and Darren is, that's about 97 kilometres from his. Okay, so that's how we'll work this graph to answer the questions. Right, so the first question, how far is David from the town when Darren starts his journey? Well, Darren starts his journey at 10 o'clock. So we'll go up there, we'll hit David's graph, and David at 10 o'clock is 75 kilometres from his hometown. At approximately what time do their paths cross? So we're looking for time, so we'll be reading off the x-axis. Well, they cross here and here. So time 10:45 and 12:15. At what time does David begin his return journey? Well, he's getting further away from his house from here. Takes a break for a while and gets further away from his house. And at this point then he starts to get closer to his house. So at this point he starts his journey home, which is at 1:30 p.m. And these are AM. How far is Darren from the town when David begins his journey home? When David begins at 1:30, how far is Darren from his town? Well, 1:30, go up to Darren's graph, go across, and he's 75 kilometres. And who returns to town first? Well, David returns at 3:30 and Darren returns at 3 o'clock. So Darren. And what time elapses before the other motorist arrives? Well, as we said, Darren returns at 3, David returns at 3:30, so 30 minutes ago.